All right. We good?
All right, yeah, it looks like we're good.
We got it. No, we got it. We got it.
All
All
right.
right, let's get out your hair. Let's let you start up.
If I hear silence for a while, I'll come back and check the thing, and just message me via text. Is probably more likely to get to me. Okay. Hi, I'm Luke. I've been doing lots of development on Handshake. I've fallen in love with the way that Handshake has built this really great infrastructure for the internet. And basically, in my talk, we'll be sharing how these 4 different domains are resolving records in various ways. The DNS records for all 4 of these do not live on any name server. They're being resolved off the blockchain. They're being resolved off any ordinary name server. So I'm going to go through how we're doing that for each of these. And for now, I want to sort of name 2 reasons this is interesting and why we might want to resolve DNS records that don't live in any centralized name server, like putting your records on Route 53 or putting your records on Namebase. One reason is it decentralizes the subzones. Handshake does 2 things. It decentralizes the root zone, and it sort of demonopolizes the root zone, meaning you can add and remove entries via the rules of Handshake. And by decentralizing the root zone, we solve another problem, which is the vulnerability of DNS to denial of service attacks. And Handshake, because it's a blockchain based with sort of distributed nodes everywhere, it's a decentralized data structure. It is far less vulnerable to denial of service attacks, which like the ICANN's root servers are. Of course, DNS is ICANN has put in lots of effort. Any organization that runs name servers, they do a lot of work to make sure that the name servers stay up, and they do a good job doing it. But I think it's worth considering the ways that we can build resilience to these types of attacks in other ways. And so the second reason that these are resolving names this way, the second reason that it's worth considering doing this is Handshake sort of demonopolizes the root zone in that anybody can now register a TLD. But with Handshake, there's a new problem, which is that sublevel domains are vulnerable to the monopolization of TLDs. So if you want to get a sublevel domain, you really are at the whim of the TLD owner. And so you can use what I'm going to share during this talk to offer trustless sublevel domains for TLDs if you are a generous TLD owner. That's something you can do. Okay. If you want to skip to the point, this is the library that I've been working on for the developers out there. Take a look. It's still young, still needs lots of documentation, but this is the crux of my talk. You can learn here if you're familiar with how, with the tools that you need to get started. So let's start with this domain, ipf.chan0. So chan0 is a TLD that I own on the Handshake blockchain. And this is serving, we're serving the records for this domain IPFS.chan0 via a zone file stored on IPFS. And let's quick go through what it takes to do that. Hopefully y'all are still with me. I'm banking on that. Okay, so we've got this zone file here that we're going to create. HandyCon.chan0, a zone file for it, and it's got an A record and a text record. And I'm going to upload this to IPFS using this really great upload tool, which I think I already threw it in there, already listed. Let's do it again. Drop it, upload. All right, so we've uploaded this file to IPFS using the Infura gateway. And we're going to grab the hash. We're going to grab the hash, throw it into this CID inspector for IPFS to grab the base 32 encoding of it. And we need this because we're going to throw this in an NS record for chan0, which I currently have on namebase. And we're going to throw in the ._IPFS dot to indicate that this is a pointer to a file on IPFS, and any HIP5 resolver capable of handling the IPFS protocol will be able to locate the name server or the zone file for this. So we're going to set that, and since I'm repeating myself, it propagates. And you'd ideally do this on the blockchain itself. I'm doing it on Namebase's name server for convenience, which is partly what I aim to. Hopefully you'll not be putting it on Namebase's name servers, because this is exactly the purpose of this. But for the purposes of demoing, now we had a quick serve fail, but that was in the background. What was happening is we had a recursive resolver that can handle this IPFS record. And it digs up this zone file, this one that we uploaded. In fact, we can do this. Let's get the Cloudflare IPFS gateway and see that it's uploaded. There we go. So we're on Cloudflare's IPFS gateway, and we see the zone file that we uploaded. And that is what the resolver on my computer is grabbing to resolve HandyCon.chan0. In particular, it's grabbing this A record that points to my server, which serves this content. And this is the library for the IPFS protocol, HIP5 protocol, for folks interested in looking at that. But one of the main limitations of using IPFS for zone storage is that if you're storing it on the blockchain, which you should be, it takes a while to update the records, right? Every time you change your zone file, upload to IPFS, to change, you need to go to the blockchain, change the IPFS hash in your name server record in order to update things, which is super slow because it takes the blockchain 6 hours to update. And that is one of the problems that this other HIP5 protocol based on Hyperzones, which is a project that I've been focused on primarily. And Hyperzones you can think of as like IPFS zone files, except you can mutate them, you can update them, and you don't have to change the name server on the blockchain. So Luke Burns is being resolved via a hyperzone. And towards the end of this talk, I'll show you what's happening in the recursive resolver that is handling all these protocols and what it's doing. If we have time. I'm still banking on y'all being with me. So what I'll do now is quickly show you how I'm managing these things called a hyperzone. So you can install the hyperzone command line interface using this command. And once you have it installed, you can create or edit a zone. And once you do so, this is an interactive terminal session in which we have a lot of content here. This is the origin for Luke Burns. This is the public key. This is the thing that is basically, this is a public key that identifies the hyperzone. And instead of the IPFS hash, you'll use this in the NS record. And the command line interface gives you some helpful stuff. This is the DS record that you can put in the parent. This is the NS record that you should put into the parent zone on the blockchain. Both of these go on the blockchain. And you can see that this is the public key here. And I have this now on the blockchain records. This is a TLD on namebase, but now these are actually blockchain records. In here, I have the public key with a underscore hyperzone HIP5 protocol. I've got, what, 10 minutes or so, 15 minutes. Okay, so let's quick edit or add a text record. HandyCon text, hey HandyCon. And I added a HandyCon record to this hyperzone. And were we connected? If we're not connected, then this might take some time. Let's dig it and see. That was, where did we put it? HandyCon. So there we go. What happened here was, got memory leaks, but this hyperzone is replicated across all of, in this case, my recursive resolver and others out there that are using the hyperzone protocol. And then once it gets the data from that updated hyperzone, I can resolve it like I normally would. And it's pretty quick. The replication library still needs some work. So anybody interested in peer-to-peer networking, come help me. But that's how this domain is resolving via the record stored in this hyperzone, which is, where are you? Right here. So this is the DNS record by which this domain resolves, and none of this data lives on a name server. Okay, powering through. So lastly, I want to share the second part, which is rather than just serving records from some peer-to-peer, from a zone file stored on some peer-to-peer data structure, we're going to look at using HIP5, the handshake improvement proposal number 5. I don't think I mentioned that. It is just a standard for resolving records, and I'll go into more detail later on that. But This domain is using an alias, something called what I call the aliasing protocol, HIP5 protocol. And it is not grabbing records from some decentralized zone storage. It is actually a sub-level domain for this TLD, which I currently own but intend to eventually set to renew only, so I won't have any control over the records. And once I do that, anybody would be able to register a subdomain for this top level domain without going through me in any way, or without going through anyone. You don't need permission. And the way it works is you bid on a TLD on Handshake, which acts as an alias for this subdomain. All right, so this domain here is actually the alias for luke.dsub. And that only matters behind the scenes in resolving stuff. But to see how it's working, let's first look at the DSub NS records. So you've got this wild string here, similar to what we saw with IPFS and Hyperzones, but now with the aliasing protocol at the end. Ignore this for now. I've been working on gateways so that you don't actually need all of this to resolve stuff, but it's still buggy. So for now, just understand that this is the third protocol. We've looked at the IPFS protocol, the Hyperzone protocol, and now the aliasing HIP5 protocol. And this string here is just a unique ID for this TLD dsub. And we use it to deterministically generate this long string that represents luke.dsub. And I actually own this domain. I bid on it and won. And in this, in the blockchain records for this alias, I set a hyperzone. So what's happening here is luke.dsub is a trustless sublevel domain with records stored on a decentralized in a decentralized data structure. In this case, the hyperzone, and you can use whatever you want. But the idea here is that there really isn't any single server out there that can go down and cause this website to go down. And there is nobody preventing you from getting your own sublevel domain here. And the way you would do that is, let's look at this. This is how that string is being computed. I wanted the subdomain Luke, and this was the unique string that, the unique ID for dsub. If I compute that, then I get exactly that alias, right? This is how you compute the alias. It's the base 32 encoding of a Blake3 hash of the concatenation of the sublevel domain, the label that you want, plus the unique ID. And there are reasons for doing this, not just dsub here, that we can discuss if you're interested. And what did I want to do? Oh, so to get a clearer sense of what's actually happening here, now we're going to transition to, it's already been pretty dev oriented, but now it's going to be even more dev oriented. All right, so to see what exactly is happening here, firstly, this is the Hyper tool that this starts up a recursive resolver, and it uses the aliasing middleware, the IPFS middleware, and the Hyperzone middleware, which are these are libraries that I've written that you can use to resolve each of these different types of zone files and these SLDs trustlessly. Okay, so here's what's happening. When we try to resolve the A record for loop.dsub, it goes through the aliasing protocol middleware handler, and we ask, using this data, where we can get loop.dsub. And it says, oh, this is a truncation of this TLD. Oh, you can get it here at this alias. And oh, that alias is also a hyperzone. So the hyperzone middleware is grabbing that request and substituting loop.dsub for the alias and asking for the A record in the zone for this. And this is the public key for, this is the public key for the hyperzone, which is on the blockchain right here, 3CB. And then we get this answer. Here is the A record for the alias. And then the aliasing protocol comes back and says, oh, thanks. Let's turn it back into the actual sublevel domain. And that's how we get the A record. And in fact, we can do this, have a sublevel domain, which is an IPFS zone file for this subdomain. And so we're composing 3 different HIP5 middle protocols, first the aliasing, then the hyperzone, then the IPFS handlers, and it gets us back this guy right here, which is stored on IPFS. Yeah, okay, I'm still hoping you're with me. If not, I'll be sad. If you're looking for the aliasing protocol, here's the library for the middleware for that. Are you all with me?
Yeah, we're here with you, Luke. I just wanted to actually tell you that you got about 5 minutes left. There are 2 Q&A questions. I don't know if you wanted to answer them or if you just want to use this 5 minutes to keep talking about what you're talking about.
Nope, I am done. The only thing I wanted to point people to was this is all happening using a slight abuse of this HIP5 protocol, which goes like something like this, where all of these protocols work something like this. You get a request to a recursive resolver, which asks the root resolver of a handshake node for a request, and it gets the name server with this protocol. And then that's how you head off to, in this case, this is a way to resolve records stored on the Ethereum blockchain. I'm personally of the opinion that records should not be stored on blockchains. There are lots of lighter weight peer-to-peer data structures that I think are better. But this, if you're interested in it, HIP5, check it out. This is the standard that this is all based on. And the library that I'm using is Hipper under active development. Come help. That's it. Thanks for your attention.
All right, cool. And if you can touch on these Q&A really quick. Matt was just asking, can you put the website on IPFS as well?
Ooh, that's as soon as I get all of this more stable, that is the next step. In fact, I not only want to resolve websites via IPFS, I want to resolve websites via another hypercore-based data structure. The thing that hyperzones are based on are called hypercores. by the developer that goes by Macintosh, who is incredible. I highly recommend you check out Hypercore. It's amazing. So yeah, I hope to do rendering content from decentralized data structures as well. Okay, question, are the hyperzones viewable on the web or on the blockchain? They are available. So this is an important question, and I've sort of glossed over how this works. They do not live on a blockchain. And in order to get one, you need to find a peer that has one. And I think that this is a really good use case. DNS resolvers are a really good use case for being both DNS servers and DHT nodes, distributed hash table nodes, which is how you find hyperzones, right? This is how IPFS works. You grab your, you can find the content for a hash by going to a DHT, which is this data structure that's super interesting, but that's how you find it. And this works the same way. And rather than just having it out on the DHT, we'll just have a bunch of resolvers, DNS resolvers, that have a copy, a replica of a hyperzone, and they replicate it in a swarm of DNS resolvers. So yeah, I think that's my best answer to your question now. That getting that right is getting replication of hyperzones right is a big next step that I need to dig into.
All right, awesome. That's all the Q&A that we have time for. Luke, thank you for giving your time explaining HIP-5 and hyperzones. I can tell that the technical crowd liked it very much. I did not understand very much of it, but that's okay. All right, so we're gonna go into a break now, and then we'll get back with Paul Webb, and he's gonna talk about registrars and registries. So we'll see you all there.
Thanks everybody.
Yeah, thank you, Luke. Yeah, I really enjoyed that.
Kinetic is a blockchain crypto investment firm based in Hong Kong and Puerto Rico. Founded in 2016, they were the first fund in Hong Kong and one of the earliest in Asia. With a portfolio of over 220 companies, they were seed investors in such projects as Ethereum, Parity and Polkadot, Solana, FTX and of course Handshake and Namebase. Founder Johan Chu is an active investor and supporter of the Handshake ecosystem. Over 100,000 domains, co-founder of DWeb Foundation, co-founder of HandyCon, and sponsor of the Handshake House at Miami Hack Week 2022.